is the latest Zoom vulnerability, if you want to look at it that way, has been discussed today. Is any chat, even private chat between people, it will show up in the transcript. So please keep that in mind. So welcome, y'all. Glad y'all could join us. I think we have about 20 folks on right now. Chapter leadership has not changed in the last month. It is still the same team, which is great to have along. Kate Brew I believe, is on, and it looks like Tiana is on. Matt Pardo is not. I don't think he's on, but I could be wrong. Some of the other folks are not on, but they are great to help on all these different areas. Sponsor coordinator Tiana, if you ever sponsor, she's been doing lots of running around right now due to the change of the world, basically, and it's been hard stuff, and she's keeping up and doing a great job. And Matt has done some great stuff on some education stuff we will talk about later. And that is not the right machine. And if you sign up on this and you actually attended, I will see, and we'll try to get you a CPE information if you requested. Just email myself, kyle.smith@owasp.org, and we'll get it out to you upon request. And there are still opportunities to support OWASP. There's lots of volunteer opportunities. There's leadership, there's speaking opportunities. Kate Brew is the one you want to talk to, kate.brew@owasp.org. She will work with you and try to determine if you want to do a presentation for us on one of these or someplace else. And then, of course, if you want to support OWASP, there's also Amazon Smile, or if you want to do a donation from your company. OWASP is a tax-deductible 501c3 organization, and surprisingly enough, companies do matching for even OWASP, which is really nice to have. There's memberships. If you want to be a member, it's $50 for 1 year, $95 for 2 years, $500 for a lifetime, which I'm regretting not doing now after being with this group for so long. But there's also corporate memberships that are anywhere from $5,000 up to a few $100,000 that corporate companies can do now with OWASP and become much better tagging, sponsorship opportunities, other things of that nature, which we can get involved with. But if it's up to an organization, please contact Griff or myself, and we'll make sure we get you in contact with the foundational side. Otherwise, if there's any questions about membership, contact Paul Griffiths at paulgriffiths@owasp.org. We do have the mailing list still. I just approved somebody to join it just like 5 minutes ago, so it's good. We're out there. You'll get notifications about this and other OWASP Austin activities, including the happy hours, training sessions, LastCon, things like that. The study group has sort of changed. I wish Matt was on here, he'd be able to talk better to this, but it's still meeting every Thursday from 12 to 1, but it's doing virtual only. Obviously, because NI, where they usually host it, is kind of shut down right now with, not allowing us, which makes perfect sense. You want to join this, please join the OWASP Slack and the study group channel. We are also hosting a new virtual training event, which we just got set up last week, and just got the information yesterday. It'll be April 16th, starting at 6 p.m. on that Thursday night. For about 2 or 3 hours, they're going to do a kind of training and a learning session. And then after that, it's a cyber range. They'll then open up the cyber range, and anybody can test their hacking and web application security testing skills within that. If you have any questions about this, it'll be Matt Pardo. Once again, will be kind of coordinating, leading this. We'll get some more information out. We just got the information yesterday, so it's still fresh, but it is April 16th. Please feel free to put that on your calendar. It'll be April 16th through the 17th. The CTF will be open basically for 24 hours. But it looks very, very fascinating, very fun, and lots of good stuff from security innovation. LastCon 2020 is still on at this moment. Tickets are still available. October 29th through the 30th is the event itself. We were hoping to have training before that. It's still up in the air, but everything is still on. We're still at the locations. Everything is good. Hopefully the world will be back down to a little bit normality then, who knows? But right now it still looks to be good. CTF and CFP will be opening soon. We're getting all that wrangled with the foundation, and we'll have that open hopefully before the end of next month, hopefully in the week or two. Unfortunately, the upcoming chapter events, the happy hour is canceled. Contrast Security was going to be a great sponsor for us, but due to how it is right now, we've had to cancel that, and we will not be having that at the Brass Tap. So please don't go to the brass tap. Apparently some people went up to the brass tap last month, though we had sent out a cancellation notice. It is what it is. So if you go to the brass tap, I don't even think they're letting people in. They're doing delivery foods right now. Other upcoming events, I don't have a lot of information on this, so I know a lot of them are kind of up in the air because they're not face-to-face. Some things have been canceled, some things are kind of TBD. Please reach out to these organizations as you, if you're involved with them. I know B-Sides was postponed till later in the year. DevOps Days, I don't know what's gone on with that, and Houston SecCon has actually been pushed off too. But like I said earlier, we do have speaking opportunities. K-Brew is still looking for speaking opportunities, and we'll be doing, obviously, doing this virtual for at least probably the next month also. But please talk to K-Brew, kate.brew@owasp.org, and she will make all the arrangements and make all the information and get you to be a host here, presenter here. And now, you ready, Sam?
Sure, I am.
Now we have Sam. Sam has been an enterprise architect for Dell Technologies for, what, 2 or 3 years now? He worked with many other organizations too, with General Motors, Citibank, JPMorgan, things like this. That he's come up through the ranks. He's really focused on the web application, I mean the cloud security and cloud architecture. He's been AWS Architects. He's been Scrum certified. He's got a CISSP. So he's been really heavily versed in the security field for quite some time, and very heavily versed in the cloud area. So let's see if I can figure out how to pass this on to Sam. So
I think you have to, if you stop sharing, I can start sharing.
Yeah. I'll stop sharing and see what you can do here.
All right. And looks like it's
oh yes, and if there's any questions, feel free to put them into the chat and we'll try to answer them at the end.
And can you guys see the presentation? I enabled the video just for a second. Can you guys see me?
Yes.
Okay. So hi, everyone. Hope everyone's doing well. And thanks for joining in these interesting times. I'm going to turn off the video so we can preserve the bandwidth and it works better. All right. So we're going to talk about secure software. And really the fundamental behind secure software is not something that's come off today or just yesterday. It's been there for a while. But before that, who am I? And okay, so that's me. I think Kyle did an intro, so I'm not going to belabor that. The one on the right side is a barcode, QR code rather, that you can use if you're using LinkedIn app. If you scan that, you can connect with me later. All right, so the secure development, really, the fundamentals, the way we look at things is, why do we even talk about secure development? What we want to do is 2 core things, right? We want to reduce our risks. So we reduce our security, we increase our security, we reduce our risks by reducing the vectors, that attack vectors, if you will. We want to do that and not just do that just for the fun of it, but primarily it hits the bottom line, right? It's about the cost control. You want to make sure that your applications are not abused by somebody who is not supposed to, are not abused by even your regular users who have access to your applications. So fundamentally, if you look at the left side of the screen, it's the risks and costs is what we want to drive down. What do we have to give in return, right? In return, we have to make sure we improve our technical competency of our code. We increase our security posture of your code, and we increase our privacy constraints on our code. And we'll talk, these are the fundamentals on what we want to achieve as our goals. So having said that, let's go to the next one. So secure software development is not just using a tool, right? It's all of these steps. It's making sure we document our requirements. It's making sure we identify our security requirements very clearly. On top of that, we make sure our metrics and compliance reporting is able to show us if something bad's going to happen. If we are going to do threat modeling, we are going to make sure we are going to train our users, we are going to train our support staff. And so a lot of these are, if you notice, these are procedural and non-technical in nature. Apart from that, of course, there is the other pieces of it where you want to manage the security risk of third-party components. You want to make sure you perform a static code analysis, which is SAST. You want to make sure you enable dynamic analysis of your code, which is DAST. And all of these, a lot of these have tools available, but it comes down to, are we using it? Are we using them in the best possible fashion? Any questions so far before we move on? All right. I'll give a 10-second pause since I can't see hands. All right. So software development. So when we talk about the life cycle of a software development, I think most of us have developed some software in some small sense of it, at least, if not in elaborate, massive systems, right? We've written systems where we want to make sure we are doing all of the necessary pieces, whether it is requirements, the analysis, the design, the testing, the integrations, the development, the testing, that the system integration testing, volume testing, and so on and so forth. All of these steps really come together to become your software development lifecycle. And in my mind, security is a part of that puzzle. It's not an exclusion on. So there are different tools, or rather maturity models, that allow us to monitor the level of maturity in our code. Some of them are the standard CMMI, which is the capability maturity model. And then there are a handful others. I've just mentioned two here. So these models allow us to gauge the development maturity of your code, whether it's from a security standpoint, from a maintenance standpoint, from a code complexity standpoint, all of the above. Moving on. So in today's world, we talk about Agile, CI/CD, DevOps, people throw these terms around. So what, I just wanted to take a quick glance at what they really mean, right? So Agile fundamentally is all about the process, the agility of how we are going to make sure we are able to deliver fast. CI/CD is really focusing on a whole bunch of tools integrated into the life cycle of the development. And it fundamentally emphasizes automation. So if you will, scripting in a grand sense of things. And then DevOps, a lot of people put DevOps and CI/CD together. And in my mind, it's two separate things. They're tied to the hip, but they're two separate things. DevOps is more about a culture, more about a cultural responsiveness on how we are going to leverage CI/CD, how we are going to leverage Agile practices into our code. So a typical software development cycle, like we all know, starts with planning, analysis, design, implementation, testing, and maintenance, and then the cycle keeps repeating. You have next version, and so on and so forth. So when we look at security, what I want to emphasize is security needs to be there at every step of the way, right? From the point where there is application architecture, continuous validation, monitoring, infrastructure. Security should not be a bolt-on. So why DevOps in today's day and age? So a lot of our applications today were written back in the good days, I would say, for lack of better words, where these applications are what we call in the technology terms monoliths. So these are gigantic applications that have everything packed together, and making them work in a different platform is a complete nightmare. So the shift begins to happen, has happened over the last 4 or 5 years, primarily, is around breaking these big applications down into smaller chunks, essentially. And these applications, a lot of the philosophy around that is to make sure that the new generation of services, the new generation of modules that we write are very cloud native. We talk about microservices, meaning one giant service, which used to be in like 10, 15 years ago, is now no longer a single service, but rather it's split down into smaller microservices, where each of the microservice addresses a domain. And then that microservice in itself can be scaled independently, monitored independently, and allowing each of these services to interact with each other. And if there is a load on one of these certain domains, you can quickly scale just that part of your microservice segments versus scaling the whole thing. So again, there is a cost saving there and a management maintenance from a maintenance standpoint as well. And then last but not the least, the shift to containers. A lot of the apps that were developed were written to be deployed explicitly to IIS or deployed to a specific Java container, for example, right? Java app server. So that shift also has again happened where we're moving into a containerized world where now my application can be packaged, and once it's packaged, I can throw it on AWS, or I can throw it on Azure, or I can throw it on a local data center, doesn't matter. So giving ourselves the flexibility to do so. Any questions? I'm going to pause for 10 seconds and move on. Right? So a typical DevOps team, right? What do? We build, we deploy, we manage, we collaborate. It's a pretty much just well-known cycle what typical DevOps teams do and leverage as we move from a code standpoint. So what are the different tools that really come into them, right? So when we talk about DevOps, there is a whole bunch of tools here, and don't get overwhelmed with these tools, but a lot of this is used to automate. The fundamental premise around using all these tools is to leverage automation to your advantage, right? And some of these, you might come back and say, oh, well, this is nothing about the tool. Well, this is about actually monitoring, managing the tool, and relaying information. So if you're at the bottom, if you look at Slack or Confluence or Jira, it's not necessarily directly about the code, but it's about making sure we collaborate and we talk to each other and we document, right? And there are other tools like Maven, which allow you to really package things and deploy. And there is the Puppet from an infrastructure standpoint, and there is Chef and so on. And on the right side, you will see tools which are used more from a monitoring standpoint. We would have applications being monitored using App Dynamics, Dynatrace, and so on. And I'm not saying you have to use all of this, but it's always a plethora of these that come into existence for any major enterprise. And I'm talking big companies typically will have a whole combination of them. Smaller companies might have a streamlined sense of these. So let's move on to the cloud part of it. So, and I'm going to talk more about the AWS side of things. So in AWS, you can implement CI/CD in the DevOps world of things. So what you have in the DevOps world, you have the notion of a code pipeline. And a pipeline is really nothing but a set of activities that are going through the pipe, right? If you will. So just imagine a regular pipe, a plumbing pipe for that matter, and you're throwing, let's say you have 5 marbles with you, and you throw marbles from one end and you want to get it to the other. There's a certain sequence to those things that you essentially mandate. And that's what a pipeline would do. The pipeline would then in turn around and use the code build, if you will. These are individual products on AWS, by the way. And then you could deploy these from an infrastructure standpoint to EC2 instance. You could deploy this to Lambda, and so be it, right? So all of these tools come together to actually allow us to do this. So in my specific example, which I'm running towards, is we are going to be deploying to Elastic Beanstalk, which I don't know if anybody of how many of you are clearly aware of it, but so in the if you remember the earlier discussion where I said applications were being deployed to IIS or applications were being deployed to a Java-based web application server like JBoss or Tomcat, this essentially is a streamlined way to install without having to bother about the underlying infrastructure, right? And there is a lot of equivalent tools. So AWS Elastic Beanstalk is one of these products that's available from AWS. The same equivalent from Azure is called Web Apps. And an isolated product instance of that equivalent to this is PCF, Pivotal Cloud Foundry, which allows people to deploy applications. The applications themselves are packaged, and they could be Java applications, .NET applications, Python applications, Go applications, and so on. So it allows us to get away from the underlying implementation of the infrastructure as well. So what does a typical CI/CD pipeline look like, right? So what do we really want to do? So in this diagram, I want you guys to focus on the fact that it's automation, 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 right? So the moment the developer go from left to right, a developer commits, a lead developer typically would commit to a change and says, my code is done. And what do you want to happen? Do you want the code to be auto-compiled, build? Absolutely, right? So that's the second step, which the pipeline automatically takes care, because a pipeline can monitor the endpoint. The endpoint could be a Git repo for all practical purposes. But you could use any implementation of Git, whether it is GitHub, GitLab, or for that matter, AWS's code commit. And then the next steps are when the code is built with all of the dependencies, and then the build outcome is notified back. You can have an email coming back to you, or it being logged to another third system if you so desire. And then there is another set of steps that would essentially run the tests that are part of the build. You would again be notified of the test outcomes. And then the the release, once it's passes all these gates, if you will, that all the tests have run and the build was generated without errors, you would essentially be ready to deploy wherever necessary. And the deployment here could be, again, it could go as an application into a EC2 instance. It could be deployment into AWS Beanstalk. It could even be across clouds, right? You could envision this going from AWS, but you could, at the end of the build, it might go and deploy itself to AWS Beanstalk, and perhaps also deploy to Azure Web App. In a sense, maybe your cloud is multi-cloud, and you want to take advantage of the resiliency of having multiple instances by different providers. So CI/CD as a process doesn't mandate that you do certain things only a certain way. You get the choice to choose, and as long as you script it, you are able to do so. So coming into, when we talk about DevOps and how do we land into DevSecOps? Well, the acronym is pretty simple. I mean, DevOps plus security is DevSecOps. But in that picture, if you notice carefully, right? So the first picture that you saw, the previous one, you just looked at a single static pipeline where you had committed code, which was then built, and then you had tests, and then you had deployments. In this case, when you talk about DevSecOps, you really want to make sure that you take advantage of your pipeline, but introduce other checkpoints. So just imagine that previous screen you had, previous slide that I had, where this is a standard slide with no security relevance in that sense, right? So when you go look at this one, what it is doing is you want to make sure that you're reviewing your code for static code analysis, right? You want to make sure you're doing your OSS vulnerability scans. You want to make sure you capture your code metrics, and then if everything passes, then you pass to the next level, right? So in that case, notice the CI bubble, if you will, where all of those happen. Then look at the next bubble for dev, when your applications might be deployed to a dev instance, and then you might invoke a certain set of pen tests. Again, I'm emphasizing automation and not necessarily manual pen tests. And then once those scripts run, the scripts can come back and say, hey, this worked or this didn't work. Or if it did work, then different levels of errors and warnings. And then you get to choose what passes through that gate. And what I mean by that is sometimes there will be alerts that come in, which the system might flag as, let's say, level 3 alert. And you might say, it's okay, I don't really have time to fix level 3 alerts. We're going to let that slide. And sometimes in some cases, you might actually go even to the extent of saying level 2 issues, I'm going to let them slide. So you get to decide what level of maturity your code needs to be at and how you want to push the code through. The second thing in that sense of monitoring, not in that sense of all of the response you get, is you would need to make sure you look at the false positives. And obviously this is not like a one-shot day, do it one day and walk away game. You have to keep doing this on every single code commit, on every single code build, right? So you want to make sure that you leverage automation to the hilt so that every step of the way you are making sure your code is going through scanners, it's getting verified, it is getting assessed for any vulnerabilities that might pass through. And that is very, very important. We want to make sure that it happens every single time and not just one fine day in a month or in a quarter, because that obviously doesn't do well. Writing those tests, writing those scans, it takes a lot of work, yes, but once you write them, the repeatability factor is truly worth the gain. So a lot of times I've seen projects will slide on writing these and will eventually end up finding issues later on. And I always emphasize, yes, it might seem daunting, but please, please do spend the time to write these automation cases. Any questions here? I'm going to pause for 10 seconds and then move forward. All right. So in this particular demo that I was planning to do, the source code would reside in GitHub. Again, I'm going to ask you read left to right. So your source code resides in GitHub. And if you notice the center big blob, it's sitting in AWS. The code pipeline is a product in AWS, which allows me to actually monitor GitHub and pull the latest code. It goes through a code build. That code build would in turn then triggers a SonarQube scan and a Fortify scan. In my case, and then once it's fully vetted out, then it would go deploy to Elastic Beanstalk as a dummy application. So what I want to make sure I express here is the SonarQube, Fortify scan, these are just tools that I talked about, but you can use any tool that's in your arsenal, right? So you could have things like Black Duck scan, for example. You could have a Qualys scan sitting on the Elastic on this side, typically not on the Elastic, then you would do a EC2 instance. But so you could do a whole best of breed, if you will, or sometimes it's not best of breed, but rather it's more of what tools your enterprise has licensed, and then be able to push through this. So let me give you a sample. I've had some issues with the demo finally, but I'll walk you through some interesting tidbits here. So I'm going to share my screen a different way and let me know if you can see my browser. Somebody can say yes, and I'm good.
We can. We see
Okay.
your GitHub.
Okay. So thank you. So in this case, when you look at this, this is a really dummy app, right? And it's sitting in my GitHub account. And come on, this needs to go away. Sorry, there was a Zoom window that was blocking me. You wouldn't see it, but it shows up on my side. Okay. And so let me walk you through the code pipeline. What does it look like, right? So I'm in AWS. This is my account. This is my personal account. And ideally, I would have liked to show you a more bigger, greater setup, but I can't officially because that would not be the right thing to do. That would be sitting in Dell's infrastructure. So when you look at this code pipeline, right, this code pipeline is really, there are 3 stages here. If you notice it carefully, there are 3 blocks here. So first one is really taking the source that's hooked into GitLab. The second one is doing a build on that. And the third one is doing a deploy. So when you look at these steps, if you can picturize that diagram that I was sharing before, right? That's really what it is. So okay, come on. All right. So this is the code, really, the way it is written, and ignore the rest of the code noise, if you will. It's just a dummy app that doesn't do much. But what I want to show you is something called a build spec here, which is a code block that tells the pipeline exactly what it's supposed to do. Remember, these are just commands that are fired at almost at the OS level. And what it does behind the scenes when it's building it, it's the pipeline will generate a new image, if you will, a container that I have pre-set up of a certain type, of a certain capacity. And then it does execute all of these commands. So in this particular case, this is a .NET Core project. So it's typically going to be a Windows machine that it generates behind the scene. And then on that machine, it's going to generate .NET Restore. It's not a Windows machine, it's a Linux machine. We are basically doing these commands. So, and I don't know if any of you are familiar how you're familiar with the build scripts, but so these commands essentially allow the pipeline to understand what you want it to do. And these are really simple runtime commands. And in this case, I'm doing a restore, meaning clean it. This is a build. I'm cleaning out the output directory in case it's still there, which it typically does not because it's a brand new VM every single time, but this is just when I was playing with it locally. And then you publish the output, and then all these steps below are basically nothing but a way to specifically to package these things, okay, that that Elastic Beanstalk can understand. And let me show you what this thing kind of looks like. So again, not super crazy, not super rocket science, but here is this a specific AWS Beanstalk specific default. So when this is deployed, this actually is able to tell AWS Beanstalk, hey, go pick up this site.zip and go deploy it. All right. So what I want to show you back again was, so this build step, so all the steps that you saw there, let me show you if I, okay. So these build steps, again, if you've done a build locally ever, these should not be very different. But what you notice here is it does these in a container, which means it's an isolated little VM that has its life only for that span of that build. And if you notice the build commands I was issuing, so this is the restore command that it restored. So it says it's cleaned up, and then it goes and builds these DLLs in this case because it's a Windows application. And then eventually, if you notice, there were zip commands. So that's that command getting executed, and it generates basically it generates the zip file here. It says I need to do these and these. So the reason I want to show you that is I want to tell you that these build pipeline commands are not something crazy. So the moment now, if you take that same idea, by the way, the integration with Sonar Cube, I had some issue with that, and I put it out externally. But you could very well have a similar command line that will do the exact same thing with, and when you do that, what you get is a view into Sonar Cloud. So for example, once it pushes it and it analyzes it, it's going to come back and tell you, hey, I see issues with your code, right? I see concerns, and it's going to start flagging your code. Again, this code is pretty minimal, and there's nothing crazy going on other than the defaults, which it doesn't like. So here is where you would see a whole bunch of errors that would start cropping up and telling you these are the issues. And that's really what you want. Now, that script that you saw in the build, you could take these and the return response on this, and based on the severity of these things. So if you notice, there is a severity level, right? So you could then say, based on the severity, I'm not going to push through to the next environment, and it sends an email back to the developer who committed the code and say, hey, bud, look, this is your issue, go fix it. So does that all make sense to you guys?
Looks like Claire had a question.
Sure.
If she said, ask if you build for AWS and hope to also deploy in Azure, are there any cloud-specific considerations? Container portability almost seems too good to be true.
Good question. So portability is not exactly apples and apples equivalent, because the way you would write this in AWS pipeline is different from the way you would write it in Azure's. And the way to solve that is, well, I guess I have to give out a little internal information. You use tools that are directly in your control, and you manage the deployments, right? So for example, I have an application that is written with, instead of using AWS pipeline, it's using GitLab. And this application at runtime will, based on the pipelines, it can go talk to AWS and deploy to the specific AWS instance, because now I have it scripted at one place, and I get to control the build scripts, versus if you did it the way you asked, Claire, it can get challenging. If you try to do it, maintain one here and another endpoint for Azure, you would have to know to write it in a singular fashion so that you can maintain that and use automation to your advantage. So that when things change, the two scripts essentially will be updated together versus one at a time.
Are you saying you do a deploy out to AWS or Azure, depending on how you do it, but it would still, you do most of your stuff in the GitLab behind the scenes?
Correct.
Okay, gotcha.
So any questions anyone might have? I think I threw a lot of content at you guys. I want to make sure that it made sense. I think that was a great question, Claire. Thanks.
So your Sonar Cube and the Fortify aren't AWS specific. They are actually external products too, also that AWS can call out and
Correct,
query.
exactly. Yep.
Yeah.
They could be external products.
Yeah, okay. So basically plug in whichever one is your best fit.
Yes, yes. So, I mean, just for giggles here, look at this. I don't know if you can read this, but this is what the script, fully baked out version would look like. And you would essentially so notice these are pre-built commands. So you're essentially adding to another stage in that pipeline and saying, hey, first make sure my sonar scanner is all ready to go. And then you would essentially invoke a Maven-based sonar action, which is going to take your code, hit sonar, and say, give me the results back, right? And then it waits for a few seconds. In this case, waits for 5 seconds, and then says, okay, now I got my results. Now I'm going to, so you can see these are, again, Linux style commands. So you can slice and dice this 10 ways to Sunday, exactly how you want it. And then based on that, you can make a decision that, hey, my build succeeded or my build failed, or is there another subsequent action that I need to take? So my point of saying that is this is a URL for Sonar. So it could be very well inside AWS, could be in Azure, could be just about anywhere as long as it's reachable by this instance. So it's true software as a service in that sense of things. Now you can, depending on the features and products that you use, not everything is software as a service. Sometimes you will have to have a localized instance inside. Does that give people an idea of what it might look like?
Thank you, Sam. That helps.
Okay. So I think this was it, and I wanted to open it up for any other questions you guys might have.
So feel free to unmute yourself if you have a question, or type it in a chat, and I will try to, I guess, just read it like it declares. But any questions standing out there? Appears not, Sam. You got them to go into silence here, or at least they're still trying to digest. So there may be other ones. I think if there's any questions, reach out to Sam. Feel free to email myself or the Austin chapter, and we'll try to get them out to Sam. Otherwise, I'm going to say if there's nothing else, is there anything else you want to present to us, Sam?
No, I just wanted to say from a question standpoint, feel free to include me on LinkedIn.
Hey, Sam, this is Arun here. I have a question for you.
Sure.
Do you mind going back to the last screen where you were showing about SonarQube and Fortify?
Sure.
So out of curiosity, I mean, why are you not directly scanning using the Fortify? Because SonarQube and Fortify almost does similar job, right? But Fortify gives you much more tests, especially related to security.
Correct.
So I'm a little confused why.
Correct. So you're spot on. So SonarQube's security feature is what I showed on screen, but for all practical purposes, leverage Fortify because that's a much better static code analysis tool. SonarQube is more from a code complexity and code standards perspective. So you could still use SonarQube for that aspect of things and ignore the security aspect of SonarQube, and then leverage Fortify Scan to do the true SaaS-based analysis, if you will. Okay.
So I can just do two separate jobs where one can perform static code analysis. I don't need to actually send the output from SonarQube to Fortify, right?
No. I just meant in this picture, yes, you're right. I didn't imply, the indication is not to send it through SonarQube to Fortify, but rather it's a set of steps is what I was trying to show.
Okay, got it. Thanks.
Good question though, thank you. All right.
Alrighty, if there's no other questions, everyone, thank you to Sam for doing this great presentation. And
anybody has questions, they are welcome to join me on LinkedIn and ask. I'm more than happy. What I showed on screen again to Arun's question is just one of those gazillion combinations that just came to my mind, right? There's 20 ways to do this. So if there is ever a question, please don't hesitate to reach out to me. I'll give you my thoughts on it. All right. Kyle, back to you.
All right. Well, that should be it. Well, thank you all for attending, and thank you for doing the great presentation, Sam.
Thanks. Bye, guys.
Adios, folks. See you all next month.